Okay, and then the second one, we have the entire part of the segment BD, and it wants us to find just a piece of that CD. So just like the sum of the parts equal the whole, I can take the whole and subtract it from one of the parts to get the missing part. So I have the entire amount, which is 25, and I subtract that from one of my given parts, which is 19, and I get that missing part CD, which is 6 units. Remember, I use U for labeling anytime I am not given a particular measurement like inches or feet or yards. I'm going to use U for units. Questions? Okay, let's hop right on into 1-3. If you're following along, it's on page 20. We've got a ton of notes today, as usual. Okay, so we are going to be talking about midpoint and distance formula, two crucial concepts throughout all of geometry. On your midterm, on your final exam, on your quiz that's going to come up after 1.4, you will be quizzed and assessed on the midpoint formula and the distance formula, and actually segment bisector, which is also a term on this page. There's a question on your midterm about identifying a segment bisector, so be sure to understand what that means. So I'm just going to blow this up here so we can talk about it. The essential question for 1.3 is how can you find the midpoint and length of a segment on the coordinate plane? So as the name implies, the midpoint is a point that divides a segment in half. How do we note that? Well, in order to say that two segments are of equal length when they're split in half, we have certain notation that we use. So we talked about that last time. We said that segment AM is congruent to segment MB. We used our segment bars last time to denote that. And then we said those congruent segments also have equal measures. Notice that whenever I'm dividing a segment in half, as far as the picture is concerned, I'm going to use these little hash marks here, this red mark here and this red mark here. That just means that AM and BM are the same measure. If I have several segments, then I could have more than one line, but I do not want to have one that has 2 and one that has 1 hash mark if they are equal length. They either both have to have 2 or both have to have 1 or both have to have 3. The hash marks mean they're of equal length if they correspond with each other. So if one has 1 hash mark and another segment has 1 hash mark, then they're equal length. Does that make sense? Okay, great. So what are segment bisectors? The important thing that you need to remember about a segment bisector, it is a number of things, or it can be a number of things. It can be a point, it can be a ray, it can be a line, or it can be part of a lane segment. And that intersects a line segment at its midpoint. So right here in this, with this green figure, this green line, this is considered to be a segment bisector because it is a line that intersects point M, that midpoint. So they say here, line CD, and they use the line notation, is a segment bisector of AB. So just to recount, M is the midpoint, CD is the segment bisector because by definition, a segment bisector goes through the midpoint. Okay. M is also considered to be both a midpoint and a segment bisector because it's in the middle, of course, which makes it a midpoint, and it divides a segment in half, so it's considered to be both a midpoint and a segment bisector. Questions? Anyone still writing? Okay, I will give you more time. Okay, so this says in this skateboard design, we have a segment VW, and that's a segment bisector because it bisects XY at the midpoint T. So T is a midpoint, also considered to be a segment bisector, and VW is a segment bisector as well. And XT is 39.9. So like last time, I just always put the number in my picture because that's always super helpful for me. So xt, and I would encourage you to highlight things in geometry just because you're going to be dealing with a lot of shapes, and it might be easiest to just highlight so you don't get confused. So we're going to just mark that 39.9 centimeters. And let's see what it's actually asking. Find xy. So xy is the entire length from one end of the board to the other. So using our definitions, remember we have these hash marks, which means xt and ty are of equal length. I did not have to put the segment bars above xt and ty because I have an equal sign. So if part of it is 39.9 xt, what's the entire thing? How do I find it? What do I do? Well, xt is 39.9. What's ty? 39.9. So just double it. Of course, just double it. So when I double it, and I want to find xy is equal to 79.8 centimeters. Does that make sense? Don't forget again what a midpoint is and a segment bisector is, because it will rear its ugly head on your final, or your semester final. Pretty sure I saw it on there. Okay. I want you guys to answer. So it says identify the segment bisector. So on number 1, what is the segment bisector? So M being the midpoint, what else? MN. So in the cases where you have a ray or a segment as a segment bisector, you don't have to list every segment bisector. Just list the ray or the line. In this case, is MN a line, a segment, or a ray? Is it a segment? No. Is it a line? No. Is it a ray? Yeah, what makes it a ray? Yes. Yeah, it has an endpoint and it goes forever in one direction. Perfect. Yep, so that endpoint is so my segment bisector is MN, and I just want to mark it with the little ray symbol. That's my segment bisector. To find PQ, all I'm going to do is what? Double it. Right. So I have a fraction. I would suggest if you have a mixed number like this, 1 7/8, turn it into an improper fraction. Take 1 times 8 plus 7. And when you do that, you get 15/8. If that's 15/8, this is also 15/8. And then you want to just add them together or double it. 15/8 plus 15/8 is 30/8. And then change that improper fraction back to a mixed number. So 8 goes into 33 times. So how many do I have left over? I have 6 left over. And then I put that 8. And then I reduce 6/8. So that's, of course, 3 and 3/4, sorry. Units. So just some fraction work. Make sure that you know how to do that. Questions on any of this? You can ask about the fractions too if you don't remember. 2 is the same thing. Just do the same thing. Except, what's your segment bisector on number 2? M, just point M, right? So in this case, it's okay to just write point M because that's the only thing I have that's dividing it. In number 1, I didn't have to necessarily write that. Okay. So it says using algebra with segment lengths, point M is the midpoint of VW, find the length of VM. So I want to find the length of VM, which is that length right there. Well, the hash marks tell me what? The little lines. They're equal, right? VM and MW are equal lengths, so how do I solve this? I set them equal, right. So set them equal and solve. So 4x minus 1 equals 3x plus 3, and of course, solve with your algebra. So not complicated algebra, just understanding definitions in order to solve this correctly. Again, note how I kept my work organized, all my equal signs lined up. I expect the same from you. It needs to be easy to read. Okay. If I'm solving number 4 and I identified my segment bisector as line L, and I want to find RS, I need to identify, first of all, what is it that I'm trying to find? I'm trying to find this whole thing. Well, what do I know? I know that because there are hash marks here, these two things are equal. Well, why don't I just solve it? So I'm going to go ahead and solve it as before. Yes? So what does that tell me? That says that one part is 7.5 RM, so MS must be 7.5 as well. So the entire length must be 15. So 15 units. Do you see how I did that? Questions? All right. So sometimes you're asked to find the point that is exactly in the middle of a line or a segment, called the midpoint. Now, if you're given a graph, sometimes it's easy to see what the middle is, and other times it's not. So there's a particular formula that we can use to always find our midpoint. So let's say we have one point A, and that has certain coordinates, x1, y1. We don't know what they are. They can be anything, but it has an x and it has a y coordinate. And then let's say there's another point B. It has a different coordinate, x2, y2, not the same. If I want to find what's in the middle, really what I'm doing is I'm taking that average between the x's and the y's, right? So I'm adding my x's together, and I'm dividing by 2. And I'm adding my y's together, and I'm dividing by 2. And I'll have a new x and a new y that represent the point right in the middle. So midpoint is just taking the average of the 2 points on the outside to find the point in between. Questions on that concept? Just think midpoint, middle, average. Okay. Anybody need more time? All right. So one question on your quiz and test is going to ask you just to find the midpoint given 2 coordinate points. So we're just going to apply what we learned in the last slide. Find the average of the x's and the average of the y's to find our midpoint. Now, if you're given a graph, it's pretty easy to see what the answer is sometimes, but we always want to prove things algebraically. That's what we're doing. When we're using our midpoint formula, we're proving it algebraically, that this is what it is, not just from a visual standpoint. So I'm going to find that average. I'm going to take my x's and I'm going to add them together. I'm going to take 1 plus 4, and I'm going to find that average. Then I'm going to put a comma, and then I'm going to do the same thing for the y-coordinates. I'm going to take 3 plus 2, and I'm going to find that average. Now, how do we label points? Well, we always put the capital letter on the outside that corresponds with the point. So in this case, it's M. 1 plus 4 is 5 over 2. 3 plus 2 is 5. Oh, sorry. The book marked this wrong. This should be a negative, because that's a negative right here. So that's negative 3 plus 2, which is negative 1/2. Which makes sense. If you look over here to point M, that looks like it is 5/2. And then down here, it does look like it is negative 1/2. So that is that middle point there. Questions on that midpoint and how we label it and how we find it? Okay, that's one question on your test. B, the midpoint of JK is M. So they're giving us the midpoint. One endpoint is J. Find the coordinates of endpoint K. So they're giving us the midpoint. They want us to find an endpoint. So that's what makes it kind of difficult. So I'm not going to have both numbers like I did up here. I'm only going to have one of them. So I'm just going to replace what I don't have with a variable. So one endpoint is 1. That's my x. So 1 plus x. And I'm actually going to erase this parentheses. So 1 plus x over 2 is going to give me my x-coordinate of the midpoint. What's the x-coordinate of the midpoint? 2. Does that make sense? So I set up an equation to solve for the x-coordinate of the endpoint. I said to myself, I have one coordinate of the endpoint j, which is 1, right here. And I don't have the other x-coordinate of the endpoint k, so I'm just going to label it x, which I did here. I know that when I find the average of those two, I should get 2, because that corresponds to the x-coordinate of the midpoint. So now I'm just going to use algebra and solve. Multiply both sides by 2, of course, to cancel out the 2's. 1 plus x equals 4. Subtract 1 on both sides. X equals 3. Well, that makes sense, because if I look at point K down here, that's right on 3. So point K has an x-coordinate of 3. And then I'm going to do the same method to find the y-coordinate. I'm just going to replace my x with a y. So my y-coordinate is 4 for that one endpoint, plus y over 2. What am I going to set that equal to? Well, it says the coordinates of the midpoint JK is 2, 1. So I'm going to set it equal to 1, right? To that y-coordinate. Then I'm going to multiply both sides by 2. Cancel those out. 4 plus y equals 2. Subtract 4, subtract 4, and then I get y equals negative 2. And that makes sense. All right, that was a little bit more complicated, yes? Do you have questions on that? It's really just about, do you understand the definition of a midpoint? And if you do, it's a little bit of algebra. So if you understand the definition of a midpoint being in the middle and finding the average, you're just trying to figure out, okay, what do I have and what do I not have? Okay, I'm going to give you a brain break here. So, did you get that? Hopefully you did. I just found the average of A and B, the x's, average of the x's, average of the y's. 1 plus 7 over 2 is 8 over 2, which is 4. 2 plus 8 is 10 over 2 is 5. So the coordinates of my midpoint M is 4, 5. Number 2, you were supposed to take one endpoint. You have 4, 4, so that's 4 plus x. I don't know the x of the other endpoints. I'm just going to, or the x coordinate, so I just replace it with x. And then I divide that by 2. I'm given the x coordinate of the midpoint, so I set it equal to -1. Then I solve. Multiplied both sides by 2. Got 4 plus x is equal to -2. Then I solved for x and got -6. That's the endpoint, one of the other endpoints. And then I do the same thing with w. Take 4 plus y over 2, set that equal to the y coordinate of the midpoint. Solve for y, and I get -8. Do you have questions on 1 and 2? Did you get it? Good. Okay, cool. 10 of 11, and this one's going to be kind of a doozy to get through. You don't have to copy it all down. We're just going to talk about it. Really what you need to copy down is what the distance formula is, which is this. Another lovely formula you will have to memorize. So I'm going to go ahead and blow it up. This just says using the distance formula, and then what is the relationship between the Pythagorean theorem and the distance formula. So the distance formula, we're going to talk about where it comes from. So last class we talked about how to find horizontal distances and vertical distances. Distances for horizontal lines and vertical lines. And all we said was you find the difference and you take the absolute value, right? So if we look at this triangle at the top, we're going to look at all 3 triangles. If I want to know the distance of AC, I see right away that that is a horizontal line right there, correct? So that's a horizontal line. Because it's a horizontal line, I'm just going to look at the difference between the x values. That x value and that x value. So that's what they did. They said x2 minus x1, and they took the absolute value to find A, that distance. The red line is a vertical line. Because it's vertical, also, I just have to take the distance, or the difference, and then the absolute value. So they took those 2 y coordinates, y2 minus y1, found that difference, and put an absolute value bar over it. And that's how you get B. Well, if we look down here, we have A, B, and C. And we know for a right triangle, we have such a thing as A squared plus B squared equals C squared, right? So the distance formula tells us how to find the diagonal distance. With vertical and horizontal, you just have to find the difference, take the absolute value. For the diagonal, the C squared, to find C, you're going to take the square root of both sides to undo that square. You'll get C equals the square root of A squared plus B squared. Well, what was A squared? That was just my differences of my x's squared. What was B squared? That was just my differences of my y's squared. Does that make sense? And then to find that C, I just took the square root. So that's how we came up with the formula. If that was over your head, I'm sorry. It's a little bit much, I know. But just know that with diagonal lines or segments, to find the distance of that diagonal line, you're going to use a formula. You're going to take the x's and you're going to subtract them of the 2 points and square it. You're going to take the y's and subtract them of the 2 points and square it. You're going to add them together and then take the square root. We're going to be doing this so much that you'll be able to memorize the formula by the time for the test. So don't worry about that. Did this kind of sort of make sense? Okay. So let's move on. Do you need more time? You're good? Okay. Well, we've got one more slide, and then we're done. Okay, so I drew the map that corresponds so far to some of this word problem. A recycling center, oh, your school is 4 miles east and 1 mile south. So 4 miles east and 1 mile south is right here. Oh, I should move it over just slightly. So right there, that's a recycling center, or school, sorry. That's school. And then a recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. So 2 miles east and 3 miles north would be right here. And that's the recycling center. I like to label the points. So this is 0, 0. That's my apartment. My school is 4, -1. And the recycling center is 2, +3, 2, 3. All right. Estimate the distance between the recycling center and your school. So, I'm just going to draw this little line here. So, I just have to find that diagonal distance. Because it's a diagonal distance, I can't just find the difference. I have to use the distance formula. So, the distance formula starts with a square root. It says take your x's and subtract them. So I'm going to take my x's and subtract them, then square it. Then to that, I'm going to take my y's, I'm going to add, and then take my y's and subtract them, and square that. Okay, that's the distance formula. I'm just plugging it in. So I'm just going to continue here. 2 minus 4 is -2. Square. 3 minus -1 is 4. So plus 4 squared. And then, of course, I continue on. I'll continue here in blue. The square root of 4 plus 16, which is what? Square root of 20, which is approximately, since it wants me to estimate, I'm going to use approximate, 4.5 miles rounded to the nearest tenth. All right, we're done. Questions on example 4 and how to use the distance formula? No? Okay.